Hi everyone, myself B. Praveena. I'm the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the topic on Cauchy's theorem and that related problems. Okay, previously we discussed Rolle's theorem and Lagrange's mean value theorem. Under that, the next theorem is Cauchy's theorem, and I'll discuss with that related problems. Okay, what about the statement of the Cauchy's mean value theorem? Okay, here we have to consider two functions. What about that? F maps a comma b to r and g maps a comma b to r. Okay, we have to show first f comma g are continuous on closed interval a comma b, and the second one f comma g are differentiable on open interval a comma b. Okay, and here we have to assume two functions. We have to prove two are continuous and two are differentiable, and the third condition there, g dash of x not equal to 0 for all x belongs to ab, then there exists a point c belongs to ab such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. F of b minus f of a by g of b minus g of a. Here once observe whatever the third condition, this is g dash of x not equal to 0. If it is 0 means then definitely here we get the infinite term. So that here the denominator is always not equal to 0. This is the Cauchy's mean value theorem. According to that, I'll discuss some questions now. Okay. What about the first point of that? F comma g are continuous, and second point f comma g are differentiable, and third point g dash of x not equal to 0 for all x belongs to ab, then there exists a point c belongs to ab such that f dash of c by g dash of c is equal to f of b minus f of e by f of a by g of b minus g of a. Okay, from that first question, find c value by using Cauchy's mean value theorem for the functions f of x is equal to root x and g of x is equal to 1 by root x. 1 by root x in closed interval a comma b where 0 less than a less than b. Okay, f of x is equal to root x and g of x is equal to 1 by root x. For that, once observe through the theorem statement, what we have to prove first? F comma g are continuous. Okay, already we discussed in the previous concepts. If from one of the property, if the functions are differentiable means definitely what? If the two are continuous. For that, first I am verifying the two functions are differentiable or not. Okay, here f dash of x is equal to 1 by, what about the function here? F of x is equal to root x and g of x is equal to 1 by root x. What about the differentiation of that? F dash of x is equal to, okay, that is 1 by 2 root x. 1 by 2 root x. And similarly, what about g of x differentiation? That is g dash of x is, I'll write it as g of x is equal to x power minus 1 by 2. The differentiation is minus 1 by 2 into x power minus 1 by 2 minus 1 and into x power n minus 1 formula. That is minus 1 by 2 into x power minus 3 by 2. From that, I'll write it as 1 by 2 into, here x power minus 3 by 2 means I'll write it as x power 3 by 2, that is minus 1 by 2 into x into root x form. Okay, x into root x form, that is g dash of x. Similarly, what about f of x? F of x means root x, then directly that integration with the formula of x power n formula, n into x power n minus 1, from that we get directly 1 by 2 root x. So that here the two functions are differentiable. One is f of x is differentiable and another one g of x is also differentiable. If the two are differentiable means definitely what? The two are continuous. Therefore here two conditions satisfied. What about the third conditions from the Cauchy's mean value theorem? Here g dash of x value not equal to 0. Once observe there, if you are taken any value, then we have to take the g dash of x value not equal to 0. Okay, g dash of x is not equal to 0. Therefore, here three conditions satisfied from that Cauchy's mean value theorem. What about the formula? F of b minus f of a by g of b minus g of a is equal to f dash of c by g dash of c. Okay, what we are assuming, what they are given in the question, f of x is equal to root x and g of x is equal to 1 by root x. Once I'll observe, okay, 1 by root x. From that, what about f of b? F of a is equal to root a and f of b is equal to root b. And what about g of a? That is 1 by root a and g of b is equal to 1 by root b. Okay, that is here I'm substituting there. That is f of b is root b minus root a by from g of b is 1 by root b minus 1 by root a is equal to what about RHS side? F dash of c by g dash of c. What about f dash of c from that? That is 1 by 2 root c by minus 1 by 2. G dash of c is minus 1 by 2 into c root c. Okay, from that root b minus root a by root a. Okay, here I am taking the LCM. Once observe this, root b minus root a by 1 by root b minus 1 by root a. From that, and this is equal to 1 by 2 root c by minus 1 by 2c root c. Here 1 by 2 root c and 1 by root c cancel. There we get minus 1 by c. From that LHS set, that is after taking the LCM, that is root b minus root a by root a minus root b by root ab. Root ab is equal to their c, only c. From that here, after taking minus outside, the root a minus b and root a minus b cancel. That means here the remaining, here this is minus c. From that minus root ab is equal to minus c. From that, what about c value? Root ab. Therefore, c is equal to root ab. Okay, this is the answer for the from the by using Cauchy's mean value theorem. So that c is equal to what? Root ab. Therefore, a comma b greater than 0 and root ab is their geometric mean, and we have a less than root ab less than b. Therefore, c belongs to ab, which verifies Cauchy's mean value theorem. Okay, from the given functions now, we are verifying all conditions from the given functions by using Cauchy's mean value theorem, and after that we are getting that c value. What about the c value? From that, c is equal to root ab. Okay, c is equal to root ab. Therefore, Cauchy's mean value theorem verified. And c is equal to root ab. Okay, similarly I'll go through the second question, that is verify Cauchy's mean value theorem for f of x is equal to e power x and g of x is equal to e power minus x in closed interval 3 comma 7, and find the value of c, find the value of c. Okay, from that here, what is the given functions? They are given two functions. One is f of x is equal to e power x and the second one is g of x is equal to e power minus x. Therefore, first of all, we have to verify is two are differentiable or and continuous. Okay, once observe there, here f of x is equal to e power x, and whatever the derivative of that, that is e power x only. Derivative of e power x, e power x. Similarly, and g of x differential is given e power minus x, and the derivative is minus e power minus x. This is the derivative. So that the two are differentiable. If the two are differentiable means then definitely the two are continuous. The two are continuous. Okay, now That means the given functions are satisfied two conditions. One is differentiable in open interval 3 comma 7. From that it is continuous in closed interval 3 comma 7. Okay, from that, next, if the two conditions satisfied, what about the third condition from the Lagrange's Cauchy's mean value theorem? G dash of x not equal to 0. That means here g dash of x is equal to e power minus x, that is not equal to 0 for all x belongs to 3 comma 7. Therefore here f comma g satisfies the conditions of Cauchy's mean value theorem. Therefore, if there exists a point C belongs to whatever the given interval 3 comma 7, open interval 3 comma 7, such that here whatever the formula, f of b minus f of a by b minus a is equal to f dash of c by g dash of c. What about a and b values there? That is f of 3 minus f of this is f of 7, b value 7, and a is 3 by 7. Sorry, their formula g of b minus g of a, that means g of 7 by g of 3 is equal to what about f dash of c and g dash of c from the question after the differentiation, that is e power c by e power minus c. Okay, minus of e power minus c. F dash of c is e power c and g dash of c is minus of e power minus c. From that, now I'm substituting. What about f of x there? Given functions e power x and g of x is e power minus x. So that I'm substituting there. F of 7 means that is e power 7 minus e power 3 by 1 by e power 7 minus 1 by e cube is equal to e power c minus of, I'll take this e power c is also in a numerator, that is e power c. e power c. So that this is equal to right here. After taking LCM, this e power c minus e power minus 3 is equal to there plus 3. This is plus. Okay, function e power x, no? Okay, and after that here I'm taking the LCM, that is e power 3 minus e power 7 by e power 7 into e power 3 is equal to minus e power 2c. Okay, there here these two are cancelled after taking minus outside. From that minus of e power 7 into e power 3 is equal to minus e power 2c. From that here bases are equal. From that we are here minus cancel, their bases are equal, then I'll write it as e power 7 plus 3 is equal to e power 2c. From that what about 2c? 2c is equal to 7 plus 3. Therefore c is equal to what? 10 by 2. 10 by 2 means how much? 5. Therefore c is equal to 5. Once observe which is belongs to 3 comma 7. C is equal to 5 is belongs to 3 comma 7. So that all conditions satisfied for the given function f of x is equal to e power x and g of x is equal to e power minus x. The two are satisfied the differentiation. If the two are differentiable means the two are continuous and g dash of x value not equal to 0, and there exists c belongs to ab such that from that condition there, okay, c is equal to, we get 5. Okay, c value is equal to 5. That is once observe this is in open, this is belongs to 3 comma 7 only. Therefore this is the right answer. So that Cauchy's mean value theorem verified. Okay, Cauchy's mean value theorem verified. This is the concept of the Cauchy's mean value theorem. Whatever the concept, once again I'll repeat. Here the function is continuous and the function is differentiable and g dash of x not equal to 0, and if there exists c belongs to ab such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. From that we prove two questions. First one is f of x is equal to root x and the second function is 1 by root x. So from that we get c value root AB. And similarly, from the second question, verify Cauchy's mean value theorem for f of x is equal to e power x and g of x is equal to e power minus x. There also all conditions satisfied from the Cauchy's mean value theorem, and value of c is equal to 5. So that we verified two questions from the Cauchy's mean value theorem. This is very simple concept. Okay, next class we will discuss some other topics on the third unit. Thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.